Okay, so here we go. We're now looking at material in section 4.4. And the first topic in section 4.4, we discussed how to solve the what so-called exponential equation. Okay. And notice that this is not the only topic in section 4.4. Later on, we're going to move on to the same section, but we're talking about how to solve logarithm equations. So now, exponential equations, exponential equations. The point here is that my equation appears to contain exponential functions term. So some quick example would be like this. Some quick example. That would be like, say, we want to solve for 2 to the x and equals to 32. So we would like to find out how much x would be. So we would like to solve for x. Right? We would like to solve for x in the equation like such. So what I noticed here, is the variable that we're solving for appears in the exponents of my equation. So no longer the x appears in the base number any longer. The x now is acting as the power in my equation. And we would like to find out what power that is that makes the two sides equal to each other. So that's basically what's going on in these equations here. And that's why we call it exponential equation. So now, moving into the real technique of how to solve these equations, we have the two common methods here. The two common methods would be methods number one. Okay. Method number one, it's a little bit limited. However, it can be quite fascinating to use sometimes. So it's worth to mention it. So method number one, the point now is that as long as you recognize your equations to be in a form that, if you can recognize that your equation on the two sides of your equations have the exact same base number, and this is what I'm about to indicate right here. What I'm trying to indicate. So same base number, and they can have different power. But the point, once again, strictly you need to have your two bases on the two sides have to be the same. So whenever your equations satisfy having the two bases being the same, then you can just simply rearrange the equation in a way that you just simply pick on that power m on the left hand side, you set it equals to the power n on the right hand side, and there you produce for yourself another equation, and this is the equation to solve. This is the real equations, okay, to solve for x. And that's the intention. So once again, keep in mind, you can only use method number one as long as you recognize that on the two sides of the equations, the base is the same. Okay? So now, allow me to get into some quick example, and then later on in a later video clip, I'm going to show more detail of different examples so that you can learn more experience how to manipulate around with these problems. So now, on method number one, to solve as one quick example, something can come directly like this. So I can call this example number one. Okay, and as you can expect, the whole section 4.4 here, it's all about we solve for x. Okay, so now my part A in example one, the equation we look at is something like this. Let's say 5 raised to the power 2x minus 1 and equals to 5 to the x plus 2 power. Okay? So now my equation, the equation that I'm seeing in front of me, I call it, once again, exponential equation. Because the idea now is that each side of the equation contains the exponential term. And you can notice the x variable that we're solving for appears on the exponents, appears on the powers of the term itself. So now, as I observe these equations, what I'm seeing here is that right immediately that catch my attention, the two sides of the equation have the same base, and this is, I'm talking about base 5 on the two sides. Okay, on the two sides, they both contain the base 5. So as long as you have common base on the two sides, now the problem becomes easy for us. So the method number 1 is indicating you simply just need to focus on the exponents of the left-hand side. So the exponent of the left-hand side would be 2x minus 1. You would equate that exponent on the left-hand side with the exponent on the right-hand side. And so here I produce for myself an alternative equation. 2x minus 1 equals x plus 2. And this is going to be my new equation that I'm going to primarily solve this equation for my x. So this is going to be our only remaining task here, is to solve this equation here. 2x minus 1 equals x plus 2 for x. So at this point here, I hope everything becomes easy for you. Things from the beginning of the semester start coming back here. We can just simply add 1 for both sides. Okay, and that gives me 2x equals x, okay, plus 3, and then subtracting x from both sides, that gives me x equals 3, and here I solve for this is where I solve for my value of the equation, my value for x in the equation. Alright? Alright. Here we're getting into method number 2. This is method number 2 to solve for exponential equation. So now the whole point of method number 2. Now method number 2 is more universal. More universal. What it means here is that it can be solved for a larger number of problems that involves with exponential equation. The point here is that now, say when your equation becomes something like this. Quick example. Okay. So quick example. What I'm seeing here is, let's say 2 to the x and equals 3 to the 5 power, for example. Now, the situation here that I have on the left-hand side, my base is a 2. I have base 2 on the left-hand side. However, I have base 3 on the right-hand side. And base 3 here, it doesn't matter what kind of trick I'm using. I just cannot make the base 3 here. I cannot turn base 3 on the right-hand side into the same base as base 2 on the left-hand side. So this is the situation that we encounter here. The trouble that we encounter. The bases on the two sides just cannot agree. We don't have an agreement of the bases on the two-hand sides. So now that's why method number 2 is going to come in and handle this not nice situation. So what I will see now as a method, as a generalized idea of the methods. Okay? So generally, in method number 2, what's happening here is that when you have a base, some base on the left-hand side being raised to a power m, and then the equation appears as a to the m equals b to the n. This time, the bases on the two-hand side, bases are different. Okay? Are you all getting me clear so far? So the bases on the two-hand sides are all different. So now, as long as you have a situation like that, anytime you are running into a problem where the two bases on the right-hand side, no matter what you try, they just cannot agree to be a common base, then what you can do, you can rearrange the equation into something like this. First of all, I am going to just simply take natural log. I'm taking natural log of the number a itself on the left-hand side, and I multiply that natural log to m. Now m here was the power of my equation on the left-hand side. And then, once again, I'm taking natural log. Now make sure you take the same natural log on the two sides. Okay? You take natural log of b on the right-hand side, just natural log for b on the right-hand side. And you would multiply that natural log of b to the expression n, which is the power, which is the exponents on the right-hand side, and then you equate the two equations. There you produce for yourself a new equation, and this would be the equation to solve for. Equation to solve for x. Okay? And now, of course, we are going to get into the example that can make it more clear for you to see how you can use this general method number 2 right here. So in one of my, I would call this example number 2 for this general discussion. Okay? Let's say we want to solve for x. Okay? So solving for x in this problem. Now, let's create something new here. Okay? How about we want to solve 3 to the x minus 5 and equals to 4, for example. Okay? And in this equation here, once again, you can try to turn 4 into 2 squared. Okay? You can try to write 4 as an exponent, okay, as a power. So 4 is the power of 2, and set it equal to 3 to the x minus 5 on the left-hand side. However, with all the attempts, we just failed to turn into the common base. So no common base so far. That's the trouble. No common base so far. Okay? So I recognize that. Okay? And so we cannot apply method number 1 any longer. So the situation now is that you can treat what I'm seeing here is back right at the beginning of the problem. So let's start from scratch one more time. Right at the beginning of the problem. 3 to the x minus 5. Okay? And then equals 4. Now you can treat 4 here also as power 1. I'm just keeping things simple here. And so once again, we're not having common base. So what I can do is I can just simply rearrange the equation here in a way. I'm taking natural log of 3, just 3, on the left-hand side, and I multiply that. Now keep in mind, natural log itself is an existing number. I do agree that it doesn't have to be a nice looking number. However, it is an existing number out there. So what I'm doing, I'm taking natural log of 3, whatever that quantity is, I multiply that quantity to x minus 5, which came from my power of the left-hand side. Okay, and now being finished with the left-hand side, finished to arrange the left-hand side, I'm going to move on, and once again, I'm taking the natural log of just the base on the right-hand side, and I am now going to multiply to the power on the right-hand side. And this is how my equation appears as. So, cleaning it up a little bit, I have x minus 5 quantity times natural log of 3, whatever that number would be, equals to, 1 times natural log of 4, it's just simply natural log of 4. Okay? And so now at this point, keeping in mind once again, natural log of 3 or natural log of 4, they are all existing numbers out there. So what I can do is now I can just simply legally divide both sides by natural log of 3. Okay? And that would give me x minus 5 equals natural log of 4 divided by natural log of 3. And of course, if we cannot do this expression here mentally, but the calculator can help us here, 1.26. So now at this point, please do not take it any harder than it's supposed to be. The answer would just, to solve this final equation, all you do is add 5 to both sides, and that gives me x equals 6.26. And this is how I finish with my exponential equation using method number 2. Okay, so the point of method number 2 is right at the beginning when you see your problem, however way it appears as long as you can recognize the bases on the two sides. Now all you have to do is just simply take the natural log separately on each basis on the two sides, okay, and then you rearrange the powers to be the coefficient in front, to be the numbers, to be the quantity multiplied in front, and then solve it out just the way how I just did it. Okay, so that is all the methods for the method number 2 for solving an exponential equation.